So hello student. So today we are going to perform an activity or experiment. Okay, so it is a dependence of potential difference and the current passing through a conductor, and we are going to find the resistance of the conductor. And this is and again we are going to plot the graph between V and I. V for potential difference and I for current. So to perform this experiment, let us see some of the apparatus which are required. So these are the apparatus required for performing this experiment. So this is a battery eliminator. You can use a cell, or either you can use a dry cell or Lachlan cell. So this is a battery eliminator used here, and this is a voltmeter which is going to use the potential difference. So this is going to be used for measuring the potential difference. You can see it is of V volt, and the range of this voltmeter is 3 volt. So you can see the range of the voltmeter is 3 volt. And now if we talk about the voltmeter, so first of all we should know the least count of this voltmeter. Least count means what is the smallest value of the scale. One small scale reads how much value. So you can see the first 10 division is 0 to 0.5. You can see the first 10 division is from 0 to 0.5. So the least count of this device is 0.05. The least count of this voltmeter is 0.05. So 1 division 0.05. So 2 division 0.01. So 10 division 0.5. So we should know the least count of this voltmeter. So I am taking another apparatus for measurement of current. So this is called ammeter. So ammeter, we are going to use this ammeter. So it will measure ammeter up to 1. So we are going to measure ammeter up to 1 ampere. So this ammeter is of the range of 0 to 1 ampere. So let us again see the least count of this ammeter. So this count of this ammeter is, so you can see there is 10 division. 10 division is 0.2. So 1 division is 0.02. So the least count of this ammeter is 0.02, and least count of this voltmeter is 0.05. So we should know the least count of the two devices. Okay, and another apparatus which is called as a rheostat. So this is what we call as rheostat. Rheostat is also called as a variable resistance. So it is also called as a variable. We can vary the resistance. So you can see the wires. The black color here is a wire made up of standard resistance. Now you can see a connection here and the connection here. So this is a movable sliding contact. So when we slide it, then the reading or the resistance can be varied, or resistance can be decreased or increased. Okay, then this is we call one-way key. This is one-way key, and this is a plug. So we plug it and the key is closed, and we open it, the key is open. So this will act as a switch or key. We need some connecting wires also. So these are the connecting wires. These are copper wire. These are the connecting wires, copper wires, which will be used for connection between different components. So we can see some segment of connecting wires has been taken. Now look at this. The main component is this wire. This wire, we are going to find the resistance of this wire. I have taken a small length of the wire, but I have just make it so that it is wounded. Okay, that is, it is so that it can be it occupy a smaller area and a smaller length. So we are going to find a resistance of this given wire in our experiment. Okay, before starting our experiment, I will use some sandpaper. So what is the purpose of using this sandpaper is I am going to clean the insulation I'm going to clean the insulation which are on the components. Say for example, here you can see a lot of insulations are here, a lot of oxides has been formed, so we have to remove it. So by rubbing it with the properly with the, you can see, so we have to make it clean properly so that the conduction is good. Okay, now so the components, the insulations or the oxides has been cleaned by using this sandpaper. So now the connection will begin. So for this connection, so this is a positive terminal of the illuminator. This black is for negative terminal. We can vary the voltage by adjustable knob. So I will keep it at 2 volt here. So this is a positive of the voltmeter, negative of voltmeter, positive of ammeter, negative of ammeter, and since it is a rheostat resistance, it does not have any polarity. So let us start the connection, and remember this resistance whose value is to be calculated, it must be connected across the voltmeter, So let us start a calculation here. So now let us start connection. So remember all the time that an ammeter is always connected in series. Ammeter is always connected in series and a voltmeter must be connected in parallel. So that is why let us use series combination of this ammeter. So this positive of the illuminator, battery illuminator, must be connected to positive of the illuminator connected to positive of the battery, ammeter. So it must be connected here. And now the negative of the ammeter will now can be connected to the rheostat. Negative of the one, and there are two methods. I can connect it directly to the voltmeter, or I can connect it to the rheostat here. So I can connect to the rheostat. So this one I will connect here. Okay, connect it, and from the resistance. So now I will connect one more, that is our resistance. I have to connect the resistance again. Now, yeah, okay. Now I will disconnect this. Okay, so that this ammeter is connected to voltmeter. So remember that the positive of the illuminator must be connected to positive of the ammeter, and the positive of the, okay, that means from negative it must be connected to positive of the voltmeter. Okay, then after that, from the positive of the negative of the voltmeter, we will connect it to the now rheostat. We will connect it to the rheostat here. We will connect it to the rheostat, and from the other end of the rheostat, and from here, so this is one terminal, and this will be taken as the another terminal. So the connections must be tight. We should make the connection tight so there is no fluctuation in the reading. Okay, after this one end of the rheostat will go to key, and the other end of the key will be connected to the negative of the battery illuminator. So this is the circuit. Now we have to calculate the resistance of this, so that is why we have to connect it to the voltmeter. So I will connect it to the voltmeter. So here I will connect it. So I will connect this across the voltmeter. So because the voltmeter is always connected in parallel, you can see the connection here. Okay, so this is the complete connection of the circuit, and this circuit is ready for taking observations. So how can we check that the connection is correct? So for this, what we used to see is, this is voltmeter reading, this is ammeter or current reading. So look at this. If I increase, so this is one terminal of the rheostat, this is another terminal. If we increase it, then it occupies this much length of the wire, so the resistance is very high here. So if we perform like this, the resistance, look at this part, this is decreasing resistance, this will be decreasing resistance because only this portion has been taken up. So let us see here, by adjusting this value we can see whether the resistance is increased or decreased, because this particular portion, this portion is connected with this portion connected here, and this is connected here. So this portion is been considered for measuring the resistance. So it is of low resistance, high current, and this is of high resistance because it occupies this much range of the wire. Okay, now let us see whether the connection is okay. So this is a plug-in key. So before that, we will just put on the switch. 2 volt, I have kept it. Now I will plug in the key, insert it, and let us see the variation of current and the voltage. So for this, I will just look at this. When I decrease the value of resistance, then the value of V is increased, I is increased. When V decreases, I decreases. So we can say that V is directly proportional to current, which is the theory of Ohm's law. So you can see V decrease, I decrease. V increase, I increase. So now finally we will note down the value of V and the value of I for plotting the graph and for finding the resistance of this wire. Okay. So this is the observation table, observation for performing this experiment. So observation, first of all, as we have discussed about the range of the voltmeter. So the range of voltmeter that we are using is 3 volt, and the range of the ammeter that we are using is 1 ampere. So least count of the voltmeter is found to be 0.05 volt. That means one small division is 0.05 volt. Least count of the ammeter is 0.02 ampere. So observation table for B and I. So what are the parameters that we are going to measure? Observation number 1, 2, 3, 4, 5, 3, 4, and the 5. Then voltmeter reading we will mention here, ammeter reading, and the ratio of V by I, and then mean resistance. So these are the 5, 1, 1, 2, 1, 2, 3, 4, 5, 2 column to be filled. Okay. So now the reading will start. So we will plug in the key. So before that, we will keep the resistance maximum. After that, we will plug in the key. Okay, after plug in the key. Okay, now plug in the key. So this is voltmeter. We will adjust the voltmeter reading. We will see the voltmeter reading. Okay, so one scale. Here it is only one scale. Let us see the variation of voltmeter. Up to what value it can vary. So there is, we can see there is a variation of 0.5. 0.5. So it can vary up to 0.5. So that is why we will start our reading from 0.1 to 0.5. So the voltmeter reading that we are going to take is 0.1, 0.2, 0.3, 0.4, and 0.5. Then which reading? How many divisions will read 0.1? So since one small division 0.05, so 2 divisions read 0.1. So that is why what we are going to do is, okay, Yeah, right? So we will make it two small division. One division, we will adjust the position of the rheostat so that this voltmeter reaches 0.2 divisions. So if it is 2 divisions, then it is 0.1. So voltmeter 0.1. Then we will see the corresponding ammeter reading. So ammeter reading 1, 2, 3, 4. 4 divisions. 4 into 0.02. So we will see 1 division 0.02, 0.04. Okay, 4 divisions. 4 into 0.02. So 4 to the 8, 0.08. So it is 0.08. So ammeter reading here for this voltmeter 0.08. So okay, 0.8. It is 0.8. It will be 0.08. It will be 0.08. Okay, so it is that means 0.02 into 4 divisions. So after taking one reading, we will take it out. After taking one value, let us take it out. Let us make it little bit cold. Because temperature might have increased, it will affect the resistance, because resistance directly proportional to temperature. So temperature might increase. Okay, now let us take the second reading. Second reading, I will increase it to 4 divisions, which will be 0.2. So I will increase to 4 division of the voltmeter. 4 division is 0.2. So I will make it 0.2 here. 4 divisions 0.2, and corresponding ammeter reading is 0.22. That is 0.22. The reading is 10, 11. 11 into 0.2 is 0.22. Okay, this is the second reading. Now we will take third reading, 0.3. 0.3 means 6 small division. 6 small division here. 1, 2, 3, 4, 5, 6. 6 small division is taken. And now this is how many? Okay, so 10, 15, and the 16. So 16 divisions. So 0.2 into 16 is 0.2. Now 0.332. 0.32 for 0.3 volt. Now we will increase the voltage by 8 division. 8 division means 0.8. 0. How much? 0. 0. How many? 0.4. So 0.4. So this is 0.4, and the reading here is 20, 21, 22. 22 division 4.4. So it is 0.44. So it is 0.44 reading here in the ammeter. Okay, and finally we will bring it to 0.5. Voltmeter is now placed at 0.5 here, exactly at 0.5. And then look at the ammeter reading. So it is how many? So 0.4, 0.6, 0.5, 0.5, 0.5 आ गए यहाँ तक. So you can see that 0.6 से how many divisions? 0.6 से you just subtract 0. How many? 0.04. 0.04. So it is 0.56. 0.56. 0.56. Yeah. Okay, so we can see the reading here. So when it is 0.1 volt, the ammeter reading is 0.08, 0.2, 0.22, 0.3, 0.32, 0.4, 0.44, 0.5, 0.56. You can take the ratio of V by I for each reading here and make a calculation. So now we are going to see how to plot the graph of V versus I. Okay, so this is sample graph for V versus I. You can see here. So V versus I, V on x-axis, I on the y-axis. So according to this table, we are going to plot a graph. So for this, the graph is to be plotted. This is y-axis and this is your x-axis. So we will keep the position of the voltmeter reading on x-axis and the current reading on y-axis. Okay, now let us mark it. Voltmeter reading 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 volt. So this is your voltmeter reading. And ammeter reading, okay, so we will make it ammeter reading as, here also we can see 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. Now let us plot the graph here. So first, for the first reading, for 0.1 in the voltmeter reading, this is 0.08. So 0.08, 0.1, 0.08, 0.1, 0.08 here. And for 0.02, 0.22, 0.22. Two divisions. And for 0.03, 0.32. 0.3 here and 0.32. And 0.4, 0.44. 0.4, 0.4, 0.44, and 0.5, 0.56, 0.5, 0.556, 0.5, 0.55, 0.56 here. So you can see a graph, okay, you can see a straight line graph. So but here you can see that the graph must coincide from the origin. So that is why I will mark a point. So I will connect this point passing through the origin and passing through maximum of the line here. So I will plot a graph like this, which pass through the origin. So this line must pass through the origin, since it indicates that when V is 0, I is 0. So here you can see that the graph is a straight line inclined to x-axis. So this inclination is called this is a resistance. This inclined graph slope represents the resistance. Then from the graph, how we can find the resistance? Let us see here. So for this, I will mark this A and I will mark this B, and I will mark this as C. So that is why the resistance, the slope or resistance is calculated as, that is AC by AC, that is a voltmeter reading, divided by BC. Okay, so AC, that is what we can see, a cot of this particular theta, cot of theta. So this is base by height on this opposite side. So AC is what? 0.05, 0.5 minus 0.2 divided by what is BC? BC का जो highest value है, what was that? 0.56. This is at 0.56 minus what is here? 0.22. So here we get 0.5, 0.3. Okay, 0.5 minus 0.2, 0.3, 0.56 minus 0.22 is 0.4, then 3, 0.34. So 0.3 divided by 0. So we can see that 0.3 divided by 0.34, the denominator is larger, so that is why it will be less than 1, so it will be around 0.88 ohm. So this is the resistance of the given wire. Okay, so this is, we can prove the Ohm's law, that V is directly proportional. From here also we can find the resistance. So we can take the value of V by I. V is what? 0.1 divided by 0.08, this is 0.2 divided by 0.22, 0.3 divided by 0.32, 0.4 divided by 0.44, 0.56 divided by 0.5 divided by 0.56. So after division, we can take the mean by taking the sum of all the values and divided by 5. So mean x, mean r can be calculated as the sum of r1 plus r2 plus r3 plus r4 plus r5 divided by 5. So we can place the value of resistance here from the observation, and this is the observation of r from the table. Okay, so from the graph. So this proof the Ohm's law. Okay, one thing that we must keep in mind that this is y-axis, this is x-axis. So scale, don't forget to put the scale of observation. So what scale that you have choose? X-axis. We have x-axis. So 20, 10, 20, 20 small divisions. 20 division equals to 0.1 volt. And along y-axis, we take 10 division equals to 0.1 ampere. So these are the scale that we have selected for this particular graph. So you can see the resistance of the given wire. We can conclude by saying resistance of the given wire from the graph is 0.08, and the resistance of the graph by calculation, by observations, can be calculated from here. Okay, it can be calculated here. Okay, thank you.